from ETTechX, and I'm at an interesting stall. It says Cognospace, and when you look around, they've got some interesting things, really interesting. And I must say, it's mesmerizing to go around, see a lot of robotic things. I have no clue what these people are into. Let us hear it from them. This is interesting. Your name is, sir?
My name is Santosh Balu.
Santosh Balu. Mr. Santosh, would you mind talking about your products, what actually you do?
Sure, thanks for the opportunity. I'm Santosh Balu, founder CEO of this organization. I'm a former BITS Pilani alumni, worked in the US for like 12 years in various roles in banking industry, but shifted to education because this is where my passion is and I wanted to build a product for students. So we are an activity-based experiential learning platform where, we are a two-part solution. One is the curriculum that we have of about 500 plus activities spread across science, technology, engineering, arts, mathematics. And our science and math is very foundational and activity driven. So whatever kids learn in their typical classroom, they would come to our lab that we build in the school by taking over one of their classrooms and go through practical learning. So the same concept that they have done in a reading format, they would come here and do visual and experiential as well. And in addition to science and math, which is about 40% of the curriculum, we do a lot of engineering modules as well. We're not just robotics, but we cover about 15 plus engineering modules, starting from structural engineering, kinematics, paper engineering, origami, of course, robotics, automation, hydraulics, kinematics, mechanics, drones. So we are a very comprehensive curriculum, and on the technology side we use things like augmented reality where kids could project 3D models in front of them and interact with them, and then we do virtual reality for industrial field trips. So we're traveling across industries and creating these short industrial field trips, and when kids watch through virtual reality they get virtually transported to those environments, right? And then they do 3D designing and printing also in this lab. So we create a lab by taking over one of the classrooms at no upfront cost to the school, and we deploy this curriculum with the help of an educator, aided by visual content, digital content as well. So broadly this is what we are. A lot of intricate aspects are there, but I think at a high level this is my 2-minute pitch.
Lovely. Would you mind taking us around and showing some of your exhibits?
Exactly. So basically, if I have to show you, I'll start with augmented reality. So this is where mostly for biology and chemistry, which is more model based and factual sort of stuff, we try to leverage, we created our own 3D models. For example, there's a bacterial cell. Now when kids project in front of them on their table and interact with it, there's narration that's happening and then they're interacting with it, right? They can zoom in to as much level as possible, right? It is almost coming to life. They can touch anything and it would talk about it. There's a bacterial cell. Similarly, we have 50 such 3D models, digital models, that kids would use that tablet present on their workstation and project in front of them, right? And then, so this is that. Now, there's a virtual reality that I was talking about, where they would go through industrial field trips. Now, for instance, a coal mine. Even if you want to take a kid inside a coal mine, you cannot. But we went inside a coal mine and shot a tour.
Wow.
Right? So just for them to understand life cycle of these different industries. Now, these are all of our science and tech models, science and math models. For example, this is a center of gravity model, right? Before building this, they would watch a video where they understand center of gravity and take the kit and build this model. And when they remove these weights, the center of gravity shifts, right? So this is one of them. Now, this is a math model for area and perimeter, right? Area stays the same, but perimeter changes. Kids have trouble visualizing it. So there is a model for that. Now, for example, there is a types of motion model. All of our kits come in the form of these plates. They take elements and build these models like this. Now, there is a physics activity for understanding types of motion. Once they build this, linear motion, rotational motion, circular, and then random motion, right? So we are bringing that practical perspective to learning, and then some of those robotics models that they build, that is our automation kit where they build a lot of automation circuits for understanding different sensors, actuators. Now those are our structural engineering or hydropower kind of things. So we're very comprehensive. We are physical infrastructure as well as the curriculum that we have created.
Amazing, I must say.
Thank you so much.
Pleasure.
Thank you so much. Thank you so much.
Just imagine, at this age, if I'm getting so curious about what things are happening.
Yes, thank you.
kids are gonna get grown up.
Thank you so
Pleasure.
much. Thank you
Wish
so
all the
much.
very best.
Thank you so much.
From Careers Gyan, ETTechX. Thank you.